Electricity is all around you. It's used to power the lights in the room you're sitting in, the appliances that you rely on daily, and even the device you're watching this video on. But as useful as it can be, electricity can also be dangerous, especially when you work with it on a regular basis. In fact, thousands of workers are injured due to electrical hazards every year, which can result in burns, muscle injuries, and damage to internal organs. But it doesn't have to be that way. The National Fire Prevention Association provides safety guidelines and codes in the NFPA 70E standard to help you learn what should be addressed in an electrical safety program and how to establish one on your job site. In this program, we'll discuss what the NFPA 70E standard is and what it contains, as well as how to create and comply with an electrical safety program. The Occupational Safety and Health Administration, OSHA, requires employers to protect their employees from electrical hazards in the workplace. To help with this, in 1979, the National Fire Prevention Association, NFPA, created NFPA 70E, which is now the consensus standard for electrical safety. The standard is revised every 3 years to account for changes that occur in industries it affects, as well as new technology and equipment design. So it's important to stay up to date with its policies as they change. One of the key terms you need to know as you work with the standard is qualified person. NFPA 70E defines a qualified person as someone who is trained and knowledgeable in the construction and operation of equipment or a specific work method, and is trained to identify and avoid the electrical hazards that might be present with respect to that equipment or work method. Qualified persons should also know what precautionary techniques should be used in various electrical safety situations, understand electrical policies and procedures, be familiar with insulating materials, shielding materials, and insulated tools and equipment, and know what PPE should be used in specific electrical hazard situations. Because they have this specialized knowledge, they are integrally involved in creating your electrical safety program and are also responsible for writing job safety plans, supervising unqualified persons, and performing tasks such as testing and troubleshooting on electrical equipment when an electrical hazard exists. NFPA 70E has 3 chapters. Chapter 1 is the heart of the standard. It defines key terms and describes safe work practices and procedures, as well as the general requirements for maintaining electrically safe work environments. Chapter 2 examines maintenance requirements that can help keep your job site safe and protect employees from electrical hazards. Chapter 3 discusses safety requirements that should be used when handling special equipment such as batteries and lasers. There are also various informational annexes to the standard that provide additional resources and tools to help you understand and implement NFPA 70E on your job site. So how do you know if NFPA 70E applies to you and the work that you're doing? The standard specifies that it relates to any hazards associated with electrical energy during the installation, removal, inspection, operation, maintenance, and demolition of electric conductors, electrical equipment, signaling and communications conductors and equipment, and raceways. Now that you know what NFPA 70E is and what it contains, you might also wonder how your job site can comply with it. To start, it can be used to help develop your job site's electrical safety program. But remember, NFPA 70E is updated every 3 years, so you need to be aware of any changes that occur within each revision and how they might affect your program. When workers suffer injuries from electrically related accidents, the results can be career-ending and, in some cases, fatal. One of the best ways to avoid this is by putting an electrical safety program, ESP, in place on your job site, as recommended by the NFPA 70E consensus standard. While it is your employer's responsibility to create and establish this program, it's up to you to familiarize yourself and comply with it. Some policies that the program should include are identifying and minimizing electrical hazards, creating a written plan for every electrical task, documenting first-time procedures for electrical jobs, reporting and investigating all electricity-related incidents, and the implementation of electrical safety program controls. Electrical safety program controls are metrics that can be used to measure the program's effectiveness. They can include total time lost to injuries, money spent on workers' compensation, hours of employee training, the number of hazards identified and eliminated, and the number of work procedures that have been altered to create a de-energized environment. Your job site's ESP should also emphasize the importance of making employees aware of potential electrical hazards. After all, you can't identify hazards if you don't know what to look for. So your program should be designed so that you and your co-workers always understand what electrical hazards could exist on your job site. This means that you should know whenever there is an electrical hazard present in your work area, what could lead to you being exposed to an electrical hazard, what other personnel could enter the work area and be exposed to electrical hazards, changing work conditions that could lead to increased electrical hazards, and how exhaustion, illness, or distraction could affect your performance and lead to unsafe conditions or committing unsafe acts. Next, the program should provide you with specific safe work procedures that should be followed when you are working with or around electricity. For instance, it should detail how to verify that new electrically powered equipment has been installed and inspected properly. You also need to make sure that all equipment is well maintained and inspected before each use. But inspection and maintenance aren't the only procedures your ESP should address. It should also include instructions for performing specific electrically related tasks. For each task, these written procedures should include the defined scope of the task, the required qualifications for employees working on the task, the number of employees needed for the task, and the hazards associated with the task. The procedures should also address the limits of approach, how close you have to get to a piece of equipment to be at risk of an electrical hazard, safe work practices that should be followed when working on the task, any PPE that should be worn, the tools needed for the task, and any precautions that are associated with performing the task. These procedures should come with any equipment maintenance requirements, electrical diagrams, and other visual aids that you might need to safely complete the work. Another thing that your electrical safety program should include is a risk assessment procedure that helps you to identify any electrical hazards in your work area, assess the risks associated with those hazards, and implement appropriate risk controls. NFPA 70E recommends following a specific hierarchy when doing this assessment. First, trying to eliminate the hazard. Then trying to substitute the hazardous factor with a safer alternative. If that doesn't work, using engineering controls to guard against the hazard. Making everyone aware of the hazard so they can avoid it as much as possible. Using administrative controls to change procedures, training, or warning labels. And lastly, wearing PPE to protect yourself from the hazard. Remember, your ESP is a living document and should be updated as equipment and power sources on your job site change and audited at least once every 3 years. One of the most integral parts of an electrical safety program is its electrically safe work condition policy. The NFPA 70E standard requires you to establish an electrically safe work condition, ESWC, when working within a piece of equipment's limited approach boundary. The limited approach boundary is defined as the limit at a distance from an exposed energized electrical conductor or circuit part within which an electric shock hazard exists. So establishing an electrically safe work condition involves turning off power, verifying there is no electricity present, and ensuring the equipment cannot be re-energized while you're working on it. So what specific steps should you take to create an electrically safe work condition for a task that you're working on? First, use any drawings, diagrams, and identification tags that are available to determine all of the possible sources of electrical supply to the equipment that you're working with. Next, interrupt the electrical current and open the disconnecting devices for each source of electrical supply. Then release any stored electrical energy. This could be as simple as flipping a switch or unplugging a power cord. After that, you should block or relieve any non-electrical stored energy to ensure that circuit cannot be accidentally re-energized. Finally, you should follow your job site's written procedures for applying lockout and tagout devices. Your electrical safety program should include up-to-date drawings and single-line diagrams so that you can determine where the devices should be installed. The lockout-tagout procedures should also identify the person who will de-energize the equipment, the requirements for releasing stored electric or mechanical energy, how to verify that circuits are de-energized as well as the test instruments that should be used, how to verify that the equipment cannot be re-energized, any grounding requirements, and how to transfer responsibility for lockout and tagout procedures to another person if a task takes longer than one shift. When you are testing the equipment to verify that an ESWC has been established, remember to use a known source of voltage to ensure that the test instrument is working correctly, both before and after you use it on each circuit. This is called the live-dead-live test and will help to make sure that your results are accurate. As we've seen, electrical work can have shocking consequences if you don't know how to do it safely. That's why it's important to understand the NFPA 70E standard and how to establish an electrical safety program. Let's review. The National Fire Prevention Association, NFPA, created the NFPA 70E standard to help companies and their employees comply with OSHA's electrical safety requirements. NFPA 70E encourages every workplace that has electrical hazards to create and comply with a written electrical safety program. An electrical safety program should include your job site's electrical safety policies, specific procedures for any electrically related tasks, risk assessment procedures, and an electrically safe work condition policy. To establish an electrically safe work condition, you must de-energize electrical equipment, verify the absence of voltage, and ensure it cannot be accidentally re-energized while you are working. Anytime a worker needs to enter a piece of equipment's limited approach boundary, an electrically safe work condition must be established. Now that you know how to identify the electrical hazards that can exist in your workplace, and how complying with NFPA 70E can help you avoid them, you can help to keep yourself, your coworkers, and your job site safer every day. In many ways, the world runs on electricity. In this day and age, you probably rely on it to do many of your daily tasks. And for good reason. Electricity is one of the most powerful and easily accessible types of energy in the world. But just because it can be beneficial doesn't mean it's always safe. When electrical work goes wrong, it can cause a lot of damage. In fact, electrical injuries lead to hundreds of worker fatalities every year. And even if workers do survive an incident, they could be left with lifelong injuries. Fortunately, there are ways you can protect yourself from electrical incidents. The National Fire Prevention Association lays out safety guidelines and codes in its NFPA 70E standard to help you learn how to protect yourself and your coworkers from electrical hazards. In this program, we'll discuss the electrical hazards you can face and how you can avoid them by using NFPA 70E to establish safe work practices and procedures on your job site. The NFPA 70E standard addresses three main electrical hazards: electric shock, arc flash, and arc blast. An electric shock happens when an electric current runs from the source of a voltage through your body or on the surface of your skin. Anyone can experience an electric shock from a household appliance, frayed extension cord, or a wall outlet. These types of shocks typically result in minor injuries. But when you're shocked by a piece of construction equipment, a live wire, or a power line, your injuries can be much more serious and include burns, seizures, loss of consciousness, and internal organ damage. But as serious as these injuries are, they are mild compared to what can happen during an arc flash event. This is an electrical explosion that occurs when air becomes the conductor of electricity, which can cause a heated wave of plasma that can be as hot as 35,000 degrees Fahrenheit. The light and heat from the explosion is called an arc flash, while the pressure wave that follows is called an arc blast, and it can be powerful enough to knock you off your feet. During an arc flash event, the clothes of anyone in the area can be ignited and burn their skin. The light, heat, and pressure wave can also cause eye injuries and hearing loss. And since arc flashes can burn metal, even simply inhaling can cause serious damage to your lungs. If the arc flash and blast are powerful enough, the event can be fatal, even if it only lasts microseconds. Arc flashes and blasts can be caused by a number of things, including voltage spikes, worn or loose connections in power cords, gaps in insulation in tools or equipment, improperly installed electrical parts, and dust buildup and corrosion on electrical equipment. So it is vital to use the safe work practices and procedures in the NFPA 70E standard to help avoid these types of incidents. The keys to safe electrical work are planning and preparation. The better you can assess and plan for risks, the better you can avoid them. That's why the NFPA 70E standard requires creating a job safety plan before starting any work that involves exposure to electrical hazards. It should be written by a qualified person, who is most often the employee in charge of the job. If it's your responsibility to write the job safety plan, you should include a description of the job and the tasks it consists of, the electrical hazards associated with each task, an electric shock risk assessment, an arc flash risk assessment, the work procedures that are involved with the task, and an emergency response plan in case something goes wrong. But even the most detailed and thought-out plans can go wrong if the equipment that you're using is damaged or defective. So you need to make sure that your equipment and test instruments are approved for the purpose you're using them for, and that you read the manufacturer's instructions for their operation. The NFPA 70E standard also specifies that you should visually inspect all test instruments, equipment, and accessories for defects and damage before each use. One way to verify that test instruments are working properly is through the live dead live test. This involves attaching the instrument to a known source of voltage before and after you use it to test for the absence of voltage on the machinery that you're working with. When you have verified that all of your equipment is ready to use, you need to conduct risk assessments for electric shock and arc flash hazards. These assessments identify any hazards, estimate the likelihood of a potential injury or adverse health effect, and determine what protective measures are needed to complete a task safely. During the assessment, you need to determine the voltage of all the conductors in your vicinity and the voltage ratings of the tools you're going to use. You should also consider the design of the equipment that you're working on and how well it has been maintained. These factors can help you calculate the electric shock protection boundaries using the table that the NFPA 70E standard provides. These barriers should be marked using signs or other visual indicators. There are two types of electric shock protection boundaries: the limited approach boundary and the restricted approach boundary. The NFPA 70E defines the limited approach boundary as an approach limit at a distance from an exposed energized electrical conductor or circuit part within which an electric shock hazard exists. And the restricted approach boundary is the approach limit at a distance from an exposed energized electrical conductor or circuit part within which there is an increased likelihood of electric shock due to electrical arc-over combined with inadvertent movement. The main difference is that the area within a limited approach boundary poses less of an electrical risk than the area within a restricted approach boundary. So while unqualified personnel can enter the limited approach boundary with a qualified chaperone, only qualified personnel are allowed to enter a restricted approach boundary. And specialized PPE that isn't needed in a limited approach boundary may be required in a restricted approach boundary. The NFPA 70E also stresses the importance of a third boundary, the arc flash boundary, stating the arc flash boundary separates an area in which a person is likely to be exposed to a second-degree burn from an area in which the potential for injury does not likely include a second-degree burn. The standard uses 1.2 calories per square centimeter to determine an arc flash boundary because it is the distance at which there is a probability that the employee will not suffer a permanent physical injury. Although you can still experience an arc flash burn from outside the arc flash boundary, the burn is less likely to be as severe as a burn that occurs within the boundary. Once you cross the boundary, you're more likely to suffer second, third, and even fourth degree burns in the event of an arc flash. So NFPA 70E states that any body part that crosses into the arc flash boundary must be protected from the potential thermal effects of the hazard. Once you have written your job safety plan, inspected your tools and equipment, and determined what the boundaries are for the equipment that you're working on, you're ready to begin the job. Working with and around electrical equipment comes with a lot of hazards. That's why the NFPA 70E standard sets out various ways to protect yourself in these situations. One thing you can do is simply inform yourself about the equipment that you're working with by looking at their labels. All switchboards, panels, meter socket enclosures, and motor control centers should be labeled with their nominal system voltage, arc flash boundary, minimum arc rating for clothing, and the level of PPE that should be worn when working on the equipment. So it's important that the labels are legible. If a label isn't durable enough to withstand the environment it's in, or you have trouble reading it, notify your supervisor. Another thing that NFPA 70E discusses is the use of personal protective equipment, PPE. Remember, PPE is the last line of defense. Without other protection measures, it can't protect you from all of the potential injuries that could occur on its own. However, it can minimize the severity of injuries, as long as it is maintained in a safe, clean, and reliable condition. When there is the possibility of head injury, NFPA 70E requires you to wear head, face, neck, and chin protection. This can include an arc-rated hood, balaclava, or a face shield. If you wear a face shield, it needs to provide wraparound guarding to protect your face, chin, forehead, ears, and neck area. You should also wear safety glasses or goggles and ear canal inserts to protect your eyes and ears. To avoid an electric shock to your arms and hands, you need to wear rubber insulating gloves and sleeves with protectors. To guard against an arc flash, heavy-duty arc-rated leather gloves are best. And don't forget about your feet. Insulated or leather footwear can provide protection against electric shock and arc flash events as well. As for the rest of your body, you should wear arc-rated clothing, such as an arc flash suit, to protect yourself against thermal burns when you are within the arc flash boundary of the equipment you're working on or using. Regardless of the type of PPE you wear, it's important that it has a loose fit to provide additional thermal insulation and it fully covers your body. But even with all these precautions, you aren't done yet. It's also important to use the right tools and protective equipment when you're working around electrical hazards. Any tools that you work with within a restricted approach boundary area should be insulated and need to be rated for the voltages they are being used with. The NFPA 70E standard also lists physical or mechanical barriers that can be used as a protective measure when you're working around exposed energized electrical conductors that operate at 50 volts or more to prevent any accidental contact. It's also essential to understand the procedural precautions you should take while you're working around electrical equipment that can help to keep you safe. For example, The NFPA 70E standard stresses that you must be alert and aware while you're working with or near electricity or electrically powered equipment. So if you're feeling tired, sick, or distracted, alert your supervisor immediately. You should also look for safety signs and barricades that have been positioned in or around the equipment you are working with to keep you informed and away from potential hazards. To be fully aware of everything in your work area, you need proper lighting. If you can't see what you're doing, you can't safely perform a task. Similarly, you should never blindly reach into spaces that could contain exposed electrical conductors or circuit parts. NFPA 70E also warns against wearing anything that could be conductive, such as jewelry, watches, keychains, or even metal-framed glasses. And any doors or hinged panels on equipment that you're working with must be secured. Otherwise, they could swing open, exposing you to energized electrical conductors or circuits. If your job site is overcrowded or messy, it could prevent you from having clear access to the equipment or to escape passages. So before you start any project, always make sure the surrounding area is neat and clean. But in some cases, despite all of these precautions, the equipment that you're working on could fail on its own. So NFPA 70E advises that if there is any indication that electric equipment could fail, it should be de-energized immediately. If this does happen, you should not re-energize the equipment until the cause of the failure has been identified and repaired. When it comes to electrical work, safety has to be a priority. That's why it's important to be familiar with the NFPA 70E standard and comply with its guidelines. Let's review. The three main types of electrical hazards are electric shock, arc flash, and arc blast. They can lead to burns, organ damage, loss of hearing or eyesight, even death. You should develop a job safety plan that includes your risk assessments for electrical shock and arc flash for all electrical work that you do. Before beginning any electrical work, you should always establish the electric shock safety boundary and the arc flash boundary for the equipment you're working on. One way you can become familiar with the electrical equipment on your job site is by thoroughly reading their labels. You should wear PPE such as insulated gloves, leather footwear, and head and face protection when you're doing electrical work. Now that you know what type of electrical hazards you may encounter and how complying with the NFPA 70E standard can help you protect yourself from them, you can keep yourself, your coworkers, and your job site safer every day.